Deepak had completed his bachelor's in electrical engineering, right? Electrical engineering.
Yeah, I think so. It's been so long.
Okay. So at Manipal Institute of Technology. And before joining Amdocs, Deepak held account director for T-Mobile, AT&T, Sprint, Facebook, Apple and Dish during his career, and managed large network projects in North America and globally. Deepak resides in Danville, California with his wife Priya, their 2 children, and also the pet Coco. The family loves to travel and go on hikes. Deepak enjoys spending time reading, golfing, meditating, bringing, doing home, do-it-yourself projects, and also tabla. So as part of our university, Amrita Vishwa Vidyapeetham, as part of HuT Labs Humanitarian Technology Labs, I welcome Deepak to deliver this talk.
Thank you, thank you, thank you. Thank you, Ramesh. Wow, that took a while. So yeah, briefly you heard, I graduated from Manipal Institute of Technology, and I went to school. That was my undergrad in electrical engineering, and then I went to school. I had no intention of going to America. I didn't even imagine I would go to the US. One of my roommates did not apply for one university out of 10 that he applied for, and I applied for it, and they sent me an application form. And I applied for it, and I got in, and I asked my dad, what do you think? So he said, well, go try it out for 6 months and see how it is. That was 1995, so it's been 28 years. Don't know how how fast time goes. Yeah, so like Ramesh was saying, the background was started in wireless engineering. And initial days, I don't know how many of you have seen a cell phone tower here. Have you guys seen a cell phone tower? Anybody? Nobody has seen a cell phone tower? All of you should be raising your hand. Have you seen a cell phone tower? Okay. You guys are electronic students, right? That's what they told me. So what all do you see in a cell phone tower? When you see a cell phone tower, what all do you see? Cables, antennas, radios, microwave dishes, right? So the initial years of telecom needed software to do that. So it was a British telecom research project in the 90s that converted terrain data to digital, and they would bring it in. So they would bin it, and that's how the software modeling started, because before that it was all on paper. And microwave is easy because it's point to point. You just need to look at your first Fresnel zone clearance. I don't know if you guys remember that, or you've already done that. If you've done microwave design, well, all of you, at least you know who Fresnel is, right? Like, I think somewhere in 12th standard and 11th standard, there was this guy, I'm sure you heard Fresnel. And anyway, microwave design is based on that. It's a little easier because it's point to point, and all you have to make sure is the beam doesn't have any obstruction. Now that kind of changes when you go to a design of a wireless radio network, because how many of you have listened to radio in your car? A lot of you? Yeah. So do you listen to FM or AM or both? FM. Any of you listen to AM? No AM radio. So next time you listen to AM radio, put it on and go through a tunnel. I don't know if you've tried this, but the waves will get blocked, right? So, fundamentally, it's still the same basics, right? Speed equals distance over time, and inverse of time is frequency. And from there, most cell phone networks operate at 600 megahertz all the way to 4 gigahertz. So the talk of 5G, you all have iPhones or Android phones, iPhone 15 Pro, anybody, or Samsung, the latest Samsung model. that supports 5G. A lot of that is running on 3.4 to 4.2 gigahertz, right? So you do the math. So the smaller the frequency, it's going to penetrate through the building, but you're going to have losses, right? That's the fundamental of, that's what you're trying to solve. You're trying to basically design these cell phone towers so that it's nearby enough that you don't cause any electromagnetic radiation. So there is standards around it. It has to be 6 feet or so much away from the people and so on. So, and then they build the towers. The towers are placed in such a way. Where do you think you should place the towers? Like in sparsely populated areas or like heavily populated areas? Right, heavily populated areas. And what is the challenge if it's in heavily populated areas? So it's like a 10-lane highway, and you built the network, nobody shows up, and then a year later it's packed, right? So then capacity becomes an issue, then you have to add radios, and it's like a never-ending cycle. Now your operations cost has gone up, and so on and so forth, right? I mean, in India it's not a big deal. Like, I think you can pretty much put antennas wherever you want, but most, like in the US, it's very hard for cell phone carriers to actually get a site zoned. Because it has to fit within certain aesthetics, it has to kind of merge with the surroundings around. So there's a lot of challenges like that. And as technology has evolved, and since you're all in electronics and communication, a lot of your current coursework, yeah, I actually did ask my brother to send me your current curriculum, so I did look through it. Not a whole lot has changed since I did it 20 years ago, because the fundamentals is the fundamentals. I mean, that doesn't change. I think where it starts getting advanced is as you get into your final years. I think you'll start noticing how the new technologies have evolved, mainly in semiconductor technology, right? Because of the material advances that people have been able to find, right? And Moore's law, who knows what Moore's law is? What is it?
Exponential growth of semiconductors every year.
Yeah, exactly. So that's made a huge impact, right? And that's what has caused all this advancement. So what do you think is different? How long have you guys been using cell phones? 10 years? 10 years now? What do you think is different from your first phone till now? Like, in your first phone, were you able to watch Netflix? No, right? You couldn't do FaceTime and watch Netflix, right? You couldn't stream YouTube. Why do you think all that happened? It's because of all the advancement in the semiconductor technology, right? And all the algorithms, right? It makes a huge difference, right? And if you look at standards, because you came from a world of time division multiplex, and then you went into code division multiplex, and then you went further down into orthogonal frequency division multiplex, right? So that technology itself is very CPU consuming, right? So to put, why do you think Apple decided to design their own chips in the end? They used to buy it from ARM Semiconductor because you have to tailor it, and they couldn't keep up, the semiconductor company, because Intel will design it for their own needs, and they'll say, oh, you want to design a phone, I'll do something for you. But it doesn't work that way. So I think those are some of the things I wanted to give you as a background, because the concept of digital twin, it's not new. I mean, what is your understanding of a digital twin? Anybody? Just say whatever. Take a guess. I mean, twin, digital. Somebody from the back here? No? What is the definition of twin? Anybody have twins here? No? Wow. So twin, English dictionary, like a replica, right? I think it's simple. So digital twin is basically replicating what you want to do in the real world onto the computer. So why do you want to do that? How is that different from just an emulating software you guys use in the labs today, right? The difference is the software that you use in the labs, it's just a one-time thing, right? What software do you use in the labs in your today? Do you use any lab software? They don't use? That's what I'm going to do. I have to pick up somebody. And what software do you use in the lab? MATLAB. Thank you. Okay. What's your name? Nikhil. Which semester or which semester 3? Okay. So what do you do in MATLAB? Yeah, well, let's see.
We just plot the graph in MATLAB.
Like what kind of graph?
It's basically about signals.
Signals?
Yeah.
Like
It's different kinds of signals like RAM signals, step signals, like that.
okay. And is that designing a chipset or is
No,
that just
no.
a signal? So you simulate.
We're just learning the basics only.
Okay. So if MATLAB wasn't there, what would you do? How would you go about it? You have to do it on paper, right? I mean, that's how it was done.
Yeah, we just copy.
And then the labs help you.
Yeah.
So where the digital twin is just extending that. Now imagine you did your thing in MATLAB, you ran a simulation and you went home, and you came back next day and the answers are there, right? Then you don't have to recreate the whole thing again, right? You can just evolve on it. So that's the whole concept of a digital twin. It's nothing new. So I was just going with what is a digital twin, and digital twin is used in city planning, aerospace, any field you take, buildings especially, architecture, before they plan a building or present something, right? I don't know if you guys have, I don't know how many of you watch architectural shows and stuff like that on Instagram or Facebook or whatever. You're not that old yet, so it's not of interest. But when you get to my age, you start watching how to build a house and things like that. But so architecture, what else? Hospitals. They all have this thing of a digital twin. City planning, right? So if I'm going to change, for which city are you from? Trivandrum. Okay. What's your name? Vishnu. And which semester?
S3.
S3. So in Trivandrum, is there a lot of traffic?
Yeah.
Right?
Quite traffic.
Quite a lot of traffic. Yeah. So if you had to replan the city, how would you do it? Like what would you use? What tools would you use?
Some software.
Software, right? So you have to simulate traffic, like car traffic, right? And then if there is any obstructions, you got to simulate how to move it. If you have to build a bridge, right? How would you show your vision to someone, right? So you need something like a digital twin.
Design.
Right, a design. So you can do it on paper, but that's static. So you can say 2024 Trivandrum population is how much?
I don't know.
Anybody Trivandrum population? No, I'm guessing it's like what, 5 lakhs? 10 lakh people?
Maybe.
No, 5 million, sorry. 5 million people? So obviously Trivandrum will have a forecast that every year population is going to increase by 10%. So what do I do to my city, right? So that's the whole concept of a digital twin. Once they build the city, now they can make changes to the city on the fly and then let it run to see how those changes would be, right? So that's the whole concept of a digital twin. Is everybody clear? Any questions on the digital twin? Okay. So the next question is, how many of you know Cartesian coordinates? Ah, what's your name?
Amal.
Amal. Which year?
S3.
S3, okay. What is a Cartesian coordinate?
Cartesian coordinates are basically the points that are marked in a Cartesian plane, and it's used to specify a space.
Right. So it's basically getting something from an XYZ coordinate,
Coordinates, yes.
right? And then you can map it into a 3D.
3D plane,
Yes.
yes.
Okay, so that's kind of what that image is. right? Some of the math behind it to get that kind of an image, you have to start off there. So I just want to make a point that I know I was like you guys, go to school, sometimes it doesn't make sense, but I think in hindsight, it does make sense. So the more you apply that concepts, a lot of that is like much needed. So how many of you have heard of Tesla, autonomous cars? Well, there you go. How do you think autonomous cars run? Anybody? You know?
Autonomous cars run on softwares.
Software. But how does it know there's a car in front of me or not to?
Sensors and stuff.
Sensors.
Yes.
Kind of. Yes, a lot of sensors, but there's more to it. I'm looking for a word from you guys. You can Google. Whoever has phones, you can Google too. Don't feel shy.
Machine learning.
Machine learning.
Algorithms, deep learning.
Right. So the deep learning algorithms are there. But like, what tells the car, how does it map itself to the software? You're right. The machine learning needs to be there. But how does it know from point A to point B? Because if I'm driving in a straight line, and there's going to be other guys coming from all angles, so it's always assessing everything in the surrounding area. Like Tesla has 8 cameras, right? I think 1 in the back, probably 2 in the front, about 4 on the sides. It's assessing in all areas. So typically they use. How many of you have heard the word LiDAR technology? Yeah. So. Which is one of the main things in autonomous driving. So that's part of how a digital twin is also built. Even in regular world, you need something to convert 2D to 3D. Like your iPhone, when you take a picture, what happens? Or on your smartphone, what happens typically? How does a picture get translated onto your phone? Anybody? Just take a guess. I know we all get used to taking photos, but we never think of like what exactly happens in a camera. Forget about smartphone. If any of you have used a regular camera, any photographers, passionate photographers, anybody thought about how a smartphone imprints onto the takes a photo? Anybody wants to take a guess? Somebody? No? Well, you can go look it up, but essentially, it has just like recreating Cartesian coordinates, but like the reverse of it, right? It's like taking a 3D objects and then finding out the light source from each object and then bringing it back and creating a digital image. So it's the reverse is what you need to build a digital twin, right? So you all understand what is a twin and where is it used in cell phone areas. So do you know what that is? That's why I asked the question first. Like that's a cell tower, right? On the left side, right there, that's the real world. And then this is the digital twin. I know you can't read the things, but when the slide is shared, you can. Essentially, why should I do that, right? Today, to get an inventory, I have to send somebody to climb the tower. If I have to send somebody to climb the tower, basically it means money, it means risk. People die if you don't take the proper safety protocols of climbing a tower. So there's safety aspect and there's time. How many cell phone towers do you think is there in India? Take a random guess. Any number. It can be 1, it can be 1,000, it can be 1,000,000, whatever. Just take a guess. I'll just pick somebody then. What about you? Which year are you in? S3. What's your name? Ranadeep. So how many cell phone towers do you think are in India? 1 billion. Pretty close. It's around 200,000, right? So maybe if you look at antennas and cables. But the point I was trying to make was if there are 200,000 sites and I had to find crews to go climb those towers every year, imagine the cost that just adds up every year. and that's basically a company's operational cost. It's one of the worst things to do from a stock market perspective, right? Is to basically not reduce your OPEX. Everybody familiar with the term capital expenditure, operational expense? It's nothing magic. It's what you do at home when you keep a ledger and understand how much you spent for eating outside and how much money your parents spent for spending for the month, right? So it's the same concept that companies do. But so if you have to deploy crews and climb the towers, that's a lot of expense. So what companies are looking at doing is flying drones, unmanned drones, where available, because unmanned drones can be dangerous if the drones are not flown, programmed properly. But done properly, today in the US, within 4 hours, I can call somebody, have them go fly an unmanned drone at a site, and within an hour, I'll have that data in my computer on the cloud, right? That's the power of like having a digital twin. From there, depending on how detailed it is, so say for example, have you guys heard of the companies Nokia, Ericsson, Samsung? So say Samsung comes to me and says, well, your Reliance, you want to deploy 5G, but here's what you have to do. You have to upgrade all your radios to 5G in all your towers. 200,000 sites, say 100,000 sites, times 3 sectors, and that's 300,000 sectors and 2 radios per sector. So 600,000 radios you have to deploy, and this is the cost, right? And you're like, well, I don't want to really do that. Let me see what I really have now and where I really want to deploy, because I don't want to put 5G everywhere. So I have to do an audit. Well, unless you have a proper record, you're not going to be able to do an audit, right? So that's the power of a digital twin, right? Same thing, I'm talking about telecom, but the same thing applies in any field. Probably, have you heard of the company GE, Boeing, the ones who make engines? They do this all the time, right? So that's the power of a digital twin, like what it does, and why people are going there. So why now? Why wasn't this done 10 years ago? Any guesses? We already addressed this like 15 minutes ago. Somebody answered it, but why now? Again, the processing power was not there. Like, have you guys heard of a company called NVIDIA? Yes. What's so special about NVIDIA? Why is it the new kid on the block? Well, not really new, but why is NVIDIA so special now? Everybody's forgotten Intel. Everybody's forgotten Motorola. Why NVIDIA? Anybody? Why is NVIDIA so popular lately in the news? Anybody play games here? By the way, Minecraft, Halo. There you go. So which batch are you?
S3.
S3. What's your name?
Abhirup.
Abhirup. Which game do you play?
GTA,
All game?
almost.
What kind of gaming machine do you have?
I have GTX 1650 series.
GTX. That's an NVIDIA chip, right?
NVIDIA.
Yeah, exactly. So in the games you play, do you play Halo or Minecraft or?
I play GTA, Rockstar games.
So how do you think they created all those environments? Have you ever thought like how cool it is? Like they can take a room like this, and then the character moves through the room, moves through the hallways. Motion capture. But then how do they recreate this entire hall, and then make you feel like you're right in it, right? Or a racing game. If you played a car racing game, it looks like you're right there in an F1 race, right? And right, over the years has slowly matured because the graphical processing units have got better and better and better. And what NVIDIA did, how many of you have heard of ChatGPT? How many of you use it to pass your tests or your assignments? There you go, a lot of people. Great. I'm not going to say it's okay, but my kids, the first thing they did when ChatGPT came out is they both paid $20 a month and got ChatGPT subscription so they can finish their assignments faster. I was like, yeah, you can do what you want, because at the end of the day, all it takes is the professor to catch on. And ChatGPT has a school version for professors, so they can easily catch. So in the US, it's hard to cheat now, because when ChatGPT came, for 6 months, the colleges didn't know what to do. But then very soon, ChatGPT just told the professors, the colleges, here's the version. So if anybody submits something even closely to ChatGPT, it'll catch it. Not just ChatGPT, you can go use Bard, you can go use other languages, it'll still catch it, because from an algorithm perspective, it knows who could have written that thing, right? And it's easy. I mean, if you use ChatGPT for a while, you'll see that the answers are not that great, right? Because it'll keep writing the same thing, and you have to tell it to, it's called prompt engineering. You have to like prompt it and say, oh, it's pretty good what you wrote, but how about this? And then it'll slowly start learning. It's pretty good. I mean, don't get me wrong. When my brother said like, oh yeah, you're going to give this talk. So I went to ChatGPT and I said, I have to give a talk to ECE students. This is their syllabus and I need 10 slides. So it gave me the whole outline. And I looked at it and I go, wow, that's pretty complex. Like, it had a lot of stuff based on your syllabus, right? But what does that do? It just fast tracked the whole time to think. Do you need to think through it? Yes, but some of it, if you're in corporate world, it just makes that time easier, right? But where I was going with that was NVIDIA got famous because they realized they're not going to make money in gaming. They realized that graphical processing units had some limitations, and this is how far we're going to go. So 10 years ago, they consciously made a decision, which is very difficult for a big company to shift and make these supercomputers, right? And the first machine was delivered to OpenAI, the makers of ChatGPT, 7 years ago. So that's where NVIDIA started. Now their graphical processing units are like crazy fast, right? Things that used to take a day gets done, like you saw in ChatGPT. It gets it done in 30 seconds, right? I mean, by the time you go to Google, read some research paper, and then you read it again, it's an hour. You ask ChatGPT, anything within 2020 is free. It'll give you the answer within 2 minutes. How does it do that, right? It's, large language models in itself is a separate topic, but it's brilliant. But that processing power, it came from NVIDIA being able to do that. So the next one is, that's where I was going with this, right? How is AI helping? So the left side, that is a LiDAR scan of Seattle. So that's the Space Needle. That's the LiDAR scan. This is from a company we partner with. I work for a company called Amdocs. NVIDIA is one of our partners. You can look it up. We just signed like a huge agreement with them. And this company, check it out, it's called Heavy.ai. They do an amazing job of getting LiDAR technology and basically running it through NVIDIA GPUs. So we did a LiDAR scan of the city of Seattle for a customer, and the customer said, I'll give you a challenge. Typically today, if they have to decide where to put a cell site, it's in the US, they spend $400,000 to $700,000 for one cell site. So it's a huge investment. And sometimes, if you don't recoup your money, it's a waste of investment. So they said, I'll give you 10 cell sites, and this is how I measure my score. Predict, tell me where you're going to put the cell sites, and here's the traffic forecast for the next 10 years. Tell me how my network performance score will not degrade, and tell me where to put the cell sites. So we imported the LiDAR scan of the city. We imported the LiDAR. We imported all their fiber routes in the city of Seattle, all that into the tool. And then within 2 minutes, it just came up with the first iteration and said, here's where you need to put the 10 sites. Not only that, the propagation coverage from every cell site, it was able to read it in, and it kept refining it because we were feeding it live customer data. So like we're in this building and I'm talking, I'm in building. As I walk outside, I'm naturally going to gain about 3 to 6 dB. Who understands dB, by the way? Decibel. What's a decibel? So which year are you? South. Okay. Um, so you know what's your name, sir? Nive. So you know what a decibel is? It's a measure of sound, right? Yeah, yeah. So the rule of thumb is anything you add 3 dB, you double the number, right? So if you can improve a network coverage by 3 dB, that's huge, because that's literally improving a network performance by 2x. 6 dB is 4x, right? So they came to us, so we imported all this info. This would have taken to be like a 6-month project if we were to put consultants, get all the people, and I tell you this side saying, you guys, you manage the fiber plan, you guys manage the radios, you guys manage the finance, it would have been that much of an operation. All that took like less than 1 hour to put all the data, maybe 3 hours, and then 2 minutes for the tool to give the first answer. That's the power of AI in this. And the reason I was asking about GPU and photos, just as a side thing with AI, why it's getting really good. Who here knows? Have you heard of this scientist called Gauss? It's spelled Gauss. Anybody? Gauss? It's like a familiar name. Like it's an all math. Gauss. Do you know who Gauss is? Statistics. Anybody take statistics? No? Okay. Have you seen a bell curve? Like, do you know what a bell curve is in math? Okay, anyway, look it up. The mathematician, his name is Frederick Gauss. So Gaussian distribution is a very common thing in engineering schools. I hope by the time you leave and I come here next, you all have learned Gaussian distribution. The reason I'm saying this, how recent this is when games were being developed, the technology used was it's called photogrammetry, right? Photo is for light, and then it's the measure of light, right? That's how models were created, and that was a wire mesh, and it did a great job. So basically, it took 2D images and created 3D. Now, after that, the next technology, this is so recent, like 2020, is neural radiance field, right? And a paper was written in 2020, and so from photogrammetry, it went to neural radiance field, and 2023 August, a new paper was published called Gaussian splatting. And look it up, because all that is going to be possible because of AI, right? All this is like so brand new that as you learn, I hope you guys will read it and apply it and understand the math, because the math that you're going to learn is the same math. Not a whole lot has changed. And the beauty about this day and age is it's all free. It's all in GitLabs. They put all the code there. The papers are available, so you can just do however you want. Just as a fun project, like I did this. There's a company in the US. It's a startup called Luma, Luma. What I did is they use Gaussian splatting. You take your cell phone, download the app, walk around a building, a tower, and it'll recreate that whole environment on the cloud for you within a matter of minutes. So if you want to create your own game, that's how easy it is now for anybody. So if you're interested in doing things like that, check it out, and then that probably will interest you to learn how they do it. But it's immense processing power to do it. So that's where NVIDIA, is leading the forefront here. So what are the challenges? Obviously, it's creating physical assets into digital, so the data needs to be accurate. That's a big challenge, and not everything can be simulated. Anybody knows what that image is? What does this look like? These are servers, multiple servers. That's heat flowing, cold, hot. These are fiber cables. What do you think this is? Yeah, actually, well, yeah, you're right. One answer is thermal. Which year were you? S3. What's your name? Satwik. So yeah, you're right. So it's showing airflow, right? Thermal efficiency. So have you guys, anybody know how Facebook works? Facebook? You guys use it every day? No? Instagram? Anybody knows how Instagram works? Same company, by the way. WhatsApp? Anybody knows where the data flows through? It flows through a data center. That is just a representation of a data center. Facebook has only maybe 10 or 12 data centers across the world, believe it or not. Massive data centers. And they can simulate everything using a twin, right? They do all their studies, all their analysis using a twin. Things get complex because one of our customers came to us and said, we want to, so one of the customers came and said, we want to make changes to our data center, but we don't know where things will break. Like, can you help us predict it? So how would you go about it? You have to build a digital twin. They have 20,000 Cisco routers in their network. And they said, the moment I implement a configuration change, I don't know what's going to break. And how can I predict it, right? So the idea is you have to recreate a digital twin, but can you imagine the permutation and combination of 20,000 routers having so many different variations in code that they have to deploy and to predict what's going to break? It's massive. Like, so NVIDIA has a product called NVIDIA Air, which we have partnered with. It's probably, it has its own limitation. I can only create 256 nodes. But at least then I have to create 256 divided by 20,000. That many number of simulations, stitch them together. Those are practical challenges in the world today. So I know if you haven't thought about how your Instagram works, look it up at ChatGPT, and ChatGPT will tell you how it itself works. And if you're thinking about the future, by the time you guys graduate, I think the world's moving so fast, at least in the US. If you can, I highly recommend watching videos by Jensen Huang. He's the CEO of NVIDIA, and he actually gives you a world view of where AI is going to be in the next 5 years. So I would highly recommend, because I think as you guys study, just learn where you're going to apply it as well, right? If you're listening to something in class, every one of the things in your syllabus has a relevance. And Jensen basically said, OpenAI is just the beginning. Because if I go to OpenAI today and ask it something specific in a vertical, it doesn't know the answer. So it has to be taught, it has to be trained. That's what large language models are. So that's the challenge, right? I mean, to create a digital twin is not easy because the verticals matter. So where does this go? The image behind, I know you can't see it clearly from here, but the right side is actually the image of the Earth in a digital twin. So this is a real project. Look it up. I think NVIDIA and Microsoft, one of the companies have partnered. They've created a digital replica of the Earth on how to make it better. So imagine the processing power. They've taken everything that goes on in the world, in the Earth, that affects the Earth's temperature, and they're modeling it. They're trying to figure out, like, you know, people will tell you, oh, take bath only once a day, which is a good thing. Don't waste water. Da 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 da. You know, don't turn the fan on. Don't turn the light on. Yeah, I mean, it all has an impact, but to what level, right? Is it? And then all the trash in the world. Where do I go clean it up first? What do I do? I mean, it's a daunting task, right? If you tell me that, I'll be like, I'll listen to my parents, and then I'll just go do whatever I want afterwards. But this project of a digital twin is available right now for, I think people can look at it. They've actually modeled the entire Earth, and they basically got the GPUs running, trying to make the Earth a better place as a project. So those are the benefits of creating a digital twin. I don't know, how much time do I have? Okay, I left some time. If you guys have any questions, you can ask any question. Doesn't have to be about digital twin. It can be about, I don't know, whatever you guys want to ask. Anything? Any questions? Any doubts? Was it helpful? No? Um, any other questions? No? Yeah.
So, usually the electrical circuits in circuit theory, we create the um, circuit in the computer, right, before going to the lab with all the components, resistor, transistor, and all, and simulate it and get the output. Is it not the digital twin that we were already doing that? And how this digital twin is like fundamentally different from that?
So yeah, so I was saying in the first, the difference is what you're doing in the lab is very, in a way, a little bit static. The feedback loop is a very small presence of, like, for example, the previous slide. So in this, in these server racks, whatever you designed as an electrical circuit could be just one card of the multiple cards. Now put it all together, and how will it all work together, right? That's where the digital twin, that's the power of the twin, right? So one-time simulation, yeah, like you said, MATLAB, you can do it in MATLAB and simulate. So the fundamentals, will this chip work? Is it good? But then as a whole system, how is it all going to tie it together and work? That's the thing of a digital twin. So, any other questions? Any jokes? Anybody know good jokes? No? None of you know any jokes. I'm just shocked. You're like college kids, man. Guess you know good jokes. No? Go ahead. Yes. Oh, you have a joke? Your question? No, I know. I was joking.
Sir, I would like to know what you do at Amdocs.
What do I do at Amdocs? So I have two roles. I have a team of salespeople that manage T-Mobile nationally in North America. And then I also have a delivery team that's based, some people in the US and some people in India. So we have a huge office in Pune. There's about 13,500 people there. We have a huge office in Gurgaon. There's about 3,000 people there. In that team, so Amdocs as a company does billing software, mobile network services and stuff. In that, I'm in the mobile network services group. And so our company basically, on like a product like Digital Twin, we are actually working with customers to help them build a digital twin because we know the domain. We know how a mobile network works. We know what the challenges are. And then we're bringing in this partnership with NVIDIA to build the digital twin. So my role is I manage the profit and loss. So it's like a mini general manager for that group in Amdocs. So if I don't make money, I'll have to let somebody go, or they'll let me go. Welcome to the business world. So, any other questions? Okay.
So, how will this digital twin concept be useful for students during their curriculum? How can they use for their projects?
I think it's in today's world, because of the cloud, I think all this, like I said, is freely available in GitLab, and NVIDIA and Azure. All these guys are just opened it up. I can go create things, and with ChatGPT, I don't even know how to write code. I've told ChatGPT to write code that I could plug into the thing, right? Just because I have a concept. Like, I'll give you an example. Like the customer, this antenna thing I showed, I have to fly a drone. And every time I have to fly a drone, I have to call somebody or schedule it, go fly a drone. So I was thinking, oh, what if I build drone hubs across North America? And then, like Uber, I could just ask it from the app to go fly a drone. And then, or it just doesn't even have to be for anything. My kids are playing soccer. I can't make it because I'm in another city. I can watch the soccer game from the drone. Simple things. So I was thinking about a business idea. I went to ChatGPT, I wrote all this out. I said, make an algorithm that for this county, 800,000 square miles, where all should I put the drone hubs and how many do I need? And here's the kind of drones. Within like 2 minutes, it had everything laid out with the algorithm, with the code, basic framework of a code. And then I took that info. I don't know if you guys have used Midjourney and Runway, amazing products that can create images. So I took that code, I put it in, I put that thing into Midjourney and Runway, and I said, draw me a scene of a drone hub, drones taking on and off, because I wanted to show somebody the concept, how it works. Within like another 2 minutes, it had the whole thing laid out. So literally in like 15 minutes, I had a whole rough business plan draft created on what I wanted to do. That's it's all like free. It's all out there, like from a free version. So I think you guys are like at this juncture in technology that as long as you just digest the basics, because the basics never change. So whatever you're going to learn in math is the same math. But you're at this amazing point where paying focus for the next 3 years, next 5 years, because last 15 years, wherever you graduate, everybody ended up in Infosys or Wipro or Microsoft, and that's where they were all hiring. I think in the next 5 years, that's not going to happen, because we had a project that was lagging because we didn't have resources, and everybody, all the developers said it's going to take 6 months. After ChatGPT, we finished it in like 3 months, like it was done. So imagine, like, if companies are doing that, you can go to startups in Silicon Valley on LinkedIn. Like, I follow some of the startup guys, and those guys have said, they're like, this problem that I had to depend on my CTO because he had short of resource, I just went and asked ChatGPT how to solve it. It gave me the answer, and I implemented the code, on my sandbox, and then I deployed it on the live network. So that's how fast it is. So this whole software side, I think the power is going to be on people who understand hardware and people who understand how all this works, because it's come to the point where it's no longer like you can wing it. You really have to know what's going on, in that world. And I think that's what's going to make you all stand out. So, any other questions?
Yeah, so I have one more question.
Yeah.
So, how does AmpDocs support educational activities? Do AmpDocs has some like a department just promote some academic activities or something like that?
Yeah, I can check with I don't know how they do it in India. So, for example, in the US, we have it's like assigned leaders in each state or wherever offices are. They go to local universities, and they have mentorship programs, and then they'll bring them into our office. Because in Dallas, for example, we have a 5G digital lab where we can actually show this to the students. And in some cases, we actually start at 8th grade, 9th grade with kids, helping them build robots, because there are so many classes. You go to YouTube these days, one guy will say, I'll teach your kid how to fly 3 different kinds of robots in like 4 hours. But I don't know if you need that. But yeah, we have that kind of program. I think in India, mainly for wireless, it's in Gurgaon. But they do have this kind of a training. I can find out and let you guys know how to get involved. But yeah, there's a lot of information outside. Any other questions? What's your name?
I'm Srijat.
Srijat.
From my side. Yeah, we are currently using supercomputers. I wanted to know what will be the change when quantum computers are used.
What are you using supercomputers today?
No, in the
Oh.
processing. So how will quantum computer change this field completely?
I don't know. I'm not an expert, so I don't know. I think the only thing I know about quantum computing is the new computer that I think Google built for some, I don't know how many billions of dollars. I don't know if you guys saw that. They just released it 2 months ago. Google built this massive quantum computing thing, and I think that's for like solving the how to fix the Earth problem. I think that's where you'll need quantum computing, given the different variations. But for day-to-day computing, I don't know it'll change that much. So it just depends on what we're trying to solve. The data set matters, right? So have you guys heard the word machine learning, and artificial intelligence. Who can tell me what does machine learning mean? What's the difference between machine learning and artificial intelligence? Anybody? No? Oh, should I just select? Okay. I'm just going to go with the radar gun. Well, let me choose from here. How about you? Yeah. What's your name?
Vinyasa.
Binya? Which year?
SP. Second year.
Second year. So, have you heard the word machine learning
Yes.
and AI?
Yeah.
What does it mean? Like to you, what does it mean? Not the definition or anything. What does it mean to you?
Machine learning is designing the machine.
Is the mic on? I can't hear. You want to keep it close? Yeah.
Hello.
Yeah.
Machine learning is basically designing the machine or learning more of it.
Okay. And what is AI? Like artificial intelligence. Like what is that? What does that mean to you? If it's intelligent, how is it artificial? I always wondered that. I don't know the answer, but you guys have to think about that one. There's real intelligence. Then what is artificial intelligence? Anyway, something to think about. But the idea is today, everybody uses machine learning and AI just like, oh yeah, we'll do machine learning and we'll do AI. But there's a big difference between when somebody says machine learning and somebody says AI, right? So I think, focus on the math, focus on all that, because whatever you're learning here, like I said, is kind of where this is going to go. Where the world's changing in the next 5 to 10 years. So. Any other questions? Anybody wants to know my dog's name? Hey, there's a guy over there. While we're getting the mic set up, the dog's name is Coco. She's a Maltipoo. She's 7 years old. We got her when she was like that big, and now she's about that big. She's a lap dog. So anyway, trivia. Go ahead.
How does one get into this digital twin? Because I don't think the resources are as opposed to something such as web development, where we have resources in abundance.
Oh,
How does one get into digital twin?
A good question. I can walk you through. So, here's what you do. Just to understand first you got to understand why do you need a twin, right? What are you trying to solve to do the twin? I mean, it's fun. You can play games. You can create your own games. Or you want to create something, like I was saying, fix Trivandrum's problem of a traffic jam or Kochi's problem of a traffic jam. So data is available, right? As a university, I'm sure if you go ask the right people nicely, you probably will get a LiDAR scan of Kochi and Trivandrum. Take it up as a fun project. Once you get the scans of these cities, for example, right? There are free software outside. Let me think. There's I can get you the names of some of the software that are out there that you can import the data, and you can actually set up simulations in the twin, right? So maybe that's something you could do to get involved, but it's not that hard. It's not as hard as you think, because in this day and age, they're making it very easy, very accessible. So maybe after this, I can look up some of the links and I'll email it to. Okay, he just said you guys use a software called ANSYS, and ANSYS has a digital twin, but I think that's more machine engine simulation. Yeah, so that's one aspect of a digital twin. But if you want to do, gaming, or you want to simulate a city and traffic and things like that, that's also there. Oh, they have a LiDAR actually in their HuT labs. So I don't know how many of you knew that, but that's great. So you can actually take the LiDAR, do the scans, and build the twin at the same time here. So you have all that available for you guys. I mean, it's where you guys should be thinking as you progress through this.
So somebody had told us that I think it was one of the conferences recently. They had mapped their college building to make it a smart smart building, their office building. I think the Qualcomm, Ravi, yeah. So a project would be to map this college building with a LiDAR and make it a smart building and take real-time feedback and update the twin. That can be a good project for a final year project.
Yeah, I mean, is it solving world hunger? Not yet. But, you got to start somewhere small to figure out, you need to know how a cycle works and how to fix it before you go fix a spaceship, right? I mean, that's where we are, reality. But I think this is like I said, you guys are like at this point, inflection in change in technology, like you're just at the sweet spot to start learning. You have plenty of time. But if you just keep this in the back of your head, by the time you guys graduate, I mean, I'll give you an example, right? My daughter goes to UCLA. She's in final year. She's not doing anything with regards to this. Some programming, but she's in neuroscience. But I met a friend of hers, and that kid, same age as her, so 21. He sitting in UCLA for the last 2 years, doing his college, is actually doing LiDAR coding for a company in Silicon Valley. I'm like, how did they find you? He's like, well, they were looking for people, and in the US, typically the tests are done online, your first cut. If you don't pass that test, they won't call you. But yeah, the kid just did that, and they pay him a lot of money. So he's not only going to school, and he's doing this. So the world is so small right now. So if you guys have the expertise, guess what? People are going to look for that expertise, right? Not a whole lot of twins have been built. I think this is a good point to start. So, and it's data, I mean, knowledge is like open right now, accessible. And you have professors here, you can, like I said, all the papers are like freely available. Just read it. If you have doubt, just go through it in your spare time. So, any other questions?
Yeah, I think we are already 5 minutes ahead of the schedule. So, yeah, questions, any questions you guys have? He is going to be there for another at least 15 minutes with us. So, you can let me know, even if he is not there. If you just want to connect with him with some questions, you can approach me. I can connect with him. So, yeah, so we come to the end of this session. I think it was really a great session, right? To have a speaker like this who is actually working in the most modern technology, and getting such speakers in our university is really a blessing for the student community. I hope the talk was well received by you guys, and from the way you interacted, I can guess that it was well taken by you guys. So, on behalf of our university, Amrita Vishwa Vidyapeetham, and on behalf of Humanitarian Technology Labs, we would like to thank Deepak Raghavan for his wonderful talk. Thank you
Thank
very
you.
much,
Thank you.
Deepak.
No,
Yeah,
thank you for inviting me.
yeah. So, as a token of appreciation, we would just want to give a memento